It's great to see everyone. Before we get started, as always, this session's being recorded. So if you're not comfortable being recorded, please disable your video. And please keep yourself on mute until we go into the discussion session, where everyone is invited to unmute themselves and discuss, ask questions. We'll have opportunities for that. And throughout, if you have questions, you can use the chat box. Today we have a very exciting day. If we can skip to the agenda slide for the day. So we have for our speakers, we have Crow Idnani. You'll be seeing Crow quite a bit. He's a wonderful team member. He's the Community Engagement Internship Fellow from the New York Sea Grant. And we also have with us Lily Genovese, who is joining us from the New York Sea Grant office as well. It's the New York City's Department of Environmental Education, and she is New York City and Westchester County's outreach coordinator. So we're very excited. We're really diving into one of the main components of this year's program, which is about local waterway issues. And along with that, with microplastics and plastics being such a prevalent problem in so many countries, so many local areas of the world, that's what we're going to be really diving into today. Before we do that, next slide, please. Please do remember the group goals that we had set together of what we want this space to be. And being cognizant of each other's fears and how we can better support each other in all of the sessions that we do. Okay, so before we get into our the topics of today and the plastics issue and the waterway issues, just a very brief background on GIS and community mapping. And I'll just get into very briefly why this all connects to our program this year. Next slide, please. So last week with our team members, Mariam and Anela, you learned a little bit more about the geographic information science or systems. And we learned that mapping is not just about a 2D map where we are looking at places of where we're going to go, but it can be mapping of all different data that we have about people, about things. And then Anela gave great examples in detail of what those mapping can be. And of course, there are so many uses. And along with, as we're doing GIS, one other part that I wanted to introduce and highlight is, next slide, please. It is, what are some other parts of data mapping, right? So it's very common for us to think of, as I mentioned, data and mapping as something that we see, to navigate, to use, to visualize data, analyze data, which is all true. But for the especially for the scope of this program, we really want to expand that a little bit so that you are also considering data and mapping from geospatial, the physical geography of places, but also there is a written and visual component and various data beyond just that geographical information that could be incorporated into data mapping. And because our big final project is going to be for you to identify what are the important issues for you, there's an element of storytelling, which is kind of the written part. And then the story maps that you'll be creating is the visual part. So I just wanted to put that as a background for you to think about the data and mapping, not just as a geographical information, but a lot of different pieces that you're going to be threading together. One other part that we want to just bring to your attention is community mapping. So next slide, you can skip. So before I get into that, just an open question, and you can unmute yourselves or just put it in the chat. Why do we map? So this is slide 9. What are different reasons that you map? You use a map that you're mapping. Malak, go ahead.
Okay, everyone, I'm Malek. So I think we use map just to find our way easily, so we can get to our goal. Because using a map is so much easier than just going, in a random way.
Mm-hmm. Great. Bernice?
I feel like maps are able to be used as a tool to help us visualize things. It allows people to see, oh, this is our starting point and this is our ending point, and these are the different routes or different ways to get there. And maps are a great way to visualize topography as well, the features, and really showing what's in the area.
Mm-hmm. That's great. Thanks. Gianna?
We map to like organize our surroundings and the geography around us.
Mm-hmm. Great. Shriyan?
Yeah, we use a map is like a simple image of the general area around us. We can use it to reach our goal to where we need to go, or we can use it to see what's around us.
Mm-hmm. Great. Your surroundings. That's great. And then Prisha?
So a map it could be a visual representation that what everyone else said here, I'd also like to say that it can be used to show what's around us. But it can also be used in a comparison of what has changed. So we can use it to find patterns, either geographically or in temperature, at any sort of layer.
Great. Mukta?
So maps can be really be a way of like illustrating data beyond numbers, and we can actually see the physical reality and the projection of those numbers onto a map. So it's a good way to visualize it as well.
That's great. Zarella?
We can use a map to tell stories to people because they like live on the map, so they can kind of relate it to themselves and make their own connections, and we can give them information in an informative way.
Great. Fatima?
So maps can help in the management of natural resources by showing the distribution of resources like water or forest.
That's great. Great. Thank you. Wow, I think the keywords that you all shared is even more comprehensive than what I was going to share in the next slide. So if we can move to the next slide. So some keywords I heard with what you all shared are navigating to get to our goals, visualizing, organizing, taking note of our surroundings, noting patterns and change over time. It's a way of also telling a fuller, bigger stories and understanding where there are resources, right? So all of those things are kind of here. So community mapping, when we're talking about community mapping, it has elements of all of the things you just mentioned. So we're examining our communities, resources, the needs, the realities, what are the assets? And then understanding very uniquely, because every place is different and the layout is different, you're taking note, you're kind of organizing your data, taking note of the surroundings and also the perspectives within each individual community, right? And that ensures that the local realities and local perspectives and ideas can inform whatever you're planning to do by using that data. The reason why we want to really highlight community mapping in the beginning of our programs before we get into our topics is we want whatever you're getting out from the program about water issues, about plastics, to be applicable to your community and the realities of your community. And that reality might be different in each place. So it's very important that we have a very specific understanding of our own surroundings. And often when because it is something that we are part of every day physically, sometimes we might not take note of different things, whereas when someone who is new to a place might take note, right? So it's also kind of, changing your lens and seeing, okay, let me kind of get fresh set of eyes and like re-examine and look at and assess what my community is like and where there are needs. Next slide, please. So this, let's not go too deep into it. We're going to be posting the slides on Google Classroom, And we can send it out to you if you are having issues with access. But this, you don't have to do a physical tour of your neighborhood. I mean, and also if you do, please be safe and go with someone. But this is one way to take note how to go about doing community mapping. And I think this will be worth revisiting once you have a topic in mind of what you want your story maps and your solution ideation to be throughout this program. So these are just some suggested steps that you can take to take note of your own community and identify what are the needs and issues. And bringing that back to water issues, which we're going to go into. So let's not get into it too much today, but I just wanted to put it here for you to just take a look at that. There's a process to community mapping and some guiding questions you can use to take note of what are some things to take note of, both literally and figuratively, as you are reassessing and reevaluating your communities. And then one last slide from me today is there is an additional resource for if you're getting stuck throughout the weeks on how to build your project, what your project idea is. You can use the resource in the next slide. It's designed for change. When we first started this program, this group really helped us to excuse me, to get the students into really getting into their projects, coming up with an idea and walking you through the process of coming up with a project idea. So we thought it was a great resource. So this is something you can use. If we can go to the next slide. And so I'll put it in the chat as well, but this is a resource for you as you're thinking about your project ideas. With that, I'm gonna hand it over to Crow. Very excited and thankful that you're part of our program this year. Crow, thank you so much. And I'll hand it over to you for your presentation.
All right, thank you. Hi, everyone. I'm Crow. I'm with New York Sea Grant, and I'm going to be giving you a overview of microplastic pollution. But before we get into that, we have to start with plastic pollution. And plastics are everywhere. We use them in every aspect of our lives. Based on the different chemicals used, plastics can be sorted into these 7 categories, which are all used for different things and recycled into different things. They all have different additives, and because of that, they can't be recycled together. So if you want to recycle plastics, they have to be sorted individually. Most recycling centers will focus on types 1, 2, and 4 because those are the most common. So types 3, 5, 6, and 7 often won't get recycled, and even ones that do can't be recycled twice. So overall, 90% of plastics don't get recycled, which is a very large amount, and it means we're putting a lot of plastic into landfills. Microplastics are plastic particles that are less than 5 milliliters long. Simple definition. They're made up of chemicals like bisphenol A and phthalates, which have harmful effects if they end up in our body. These chemicals take a very long time to break down, which means once they're polluted and put into ecosystems, they stay there for a very long time. There are 2 types here. Primary microplastics are manufactured intentionally. So companies will put these into their products on purpose. Very common in detergents. If you ever used a soap that had little beads in it, those were microplastics. Secondary microplastics are unintentional. They occur when bigger plastic products like bottles or plastic bags break down. They release smaller particles that pollute the ecosystem and are much, much harder to clean up than larger plastics. Why do we care if microplastics end up in our environment? Does anyone want to give me some potential answers? I can't see hands raised. Hayne, could you take care of that?
Sure. Shreya?
On a it's a very big health concern because I think it has been linked to cancer, And now they're also doing studies to see whether it's linked to dementia, and sometimes it can be even linked to heart diseases because the microplastics can get clogged up in your heart. And we also care because, like you said, they're literally everywhere. They're so deeply integrated into our lifestyle unintentionally because they end up in the soil where animals eat it and then we eat those animals. They end up in the air and we breathe that air in, obviously. So I think just the fact that it's so widespread is a reason why we should care.
That was very close to a perfect answer. I don't think there's much to add, but I'll let other people go if they have anything.
Yeah, Sarah, go ahead.
I think that Shreya's points kind of summed up everything, but I'd also like to add a little something about also climate change and how it's pretty much already started and is going to continue and go worse and worse from now on, because we've already reached a point where the earth is already getting hotter and hotter. So we need a big change for us to go back to natural, if we can possibly go back to natural. Also, as she said, plastics don't go away very easily. They can be into our animals, they can be in our soil, they can be in our water, and it's going to be a huge problem in the future if we don't do anything about it. Thank you.
Yeah, you guys are taking away my talking points. Do you want to get a few more?
Sure, Bernice.
Yeah, so through biomagnification, it can really get into what we eat. These plastics really accumulated into the food, the fish, the seafood, and also that the fact that microplastics are everywhere. Like studies even found that they were found on Mount Everest. So the fact that it's found everywhere shows that how crucial microplastics is and how much we need to really acknowledge it.
All right. I think we're gonna do one more because if I get too many answers, you're gonna take everything I had to say. So last one.
All right, Veronica, go ahead.
Microplastics are really harmful to animals because the animals eat those without knowing, and then that as we also like eat many animals, we could also end up intentionally consuming.
Yeah. Fantastic points all around. A problem with microplastics is that they don't like to stay still. They will move a lot. We're going to listen to a talk from Dr. Sherry Mason talking about the harm of microplastics in the Great Lakes, but this applies everywhere. Fingers crossed the video wants to work.
We can't hear the sound though.
Is the sound not sharing?
No, I don't think so. Not for me.
All right.
We see the slide, then the video, but just the sound is not working.
I think you have to enable in Zoom the sound.
Oh, all right. Let's see if we can do that on the fly. Okay, here we go.
And other additives that are in the plastic but are not chemically bound, and so they can leach out. As the plastic is in the water, it actually provides a really nice surface for lots of other chemicals too. Things like PCBs, polychlorinated biphenyls, which were banned in the 1970s because of their known human health impacts, but they're still in the water. Polyaromatic hydrocarbons, which come raining down from the sky into our Great Lakes. These stick to the outside, and so the plastic actually becomes like little poison pills. And remember how small these little poison pills are. They're so incredibly tiny that they can be easily ingested by organisms at the very base of the food chain, zooplankton. And they can be carried through these organisms up the food chain and ultimately into us, carrying those chemicals all along the way. So why should we care? Because ultimately, we are water. Our planet is 70% water, our bodies are 70% water, and I don't think that's coincidence. Our skin kind of creates this illusion that somehow we are separated from our environment, but we're not. If it's in the water, it's in us.
So she talked a lot about water, and that's because when microplastics get into water, that's where they really have the most opportunity to affect us and affect ecosystems. So I'm going to give you a 6-step process on how microplastics move. So we use plastics everywhere. We use them for our bags, our bottles, and we produce a lot of plastic waste. Microplastics from that waste break down and make their way into our terrestrial environment. So that's on the land. So in our immediate surroundings, in our neighborhoods, you'll see a lot of litter and a lot of smaller particles that are much harder to clean up. From there, rainwater carries these microplastics into the water, into aquatic ecosystems. A watershed is all of the land that a river drains. So all of the land around a river or a body of water, all the runoff is going to end up in that river. So we're going to get to that in a bit, actually, so I won't talk about it too much. From there, once the microplastics are in the water, small organisms, like she talked about, will ingest the microplastics. These are the base of the food chain, like zooplankton. So tiny organisms will ingest these microplastics. And then also, like she said, and like some of you said, larger organisms will eat these small organisms, and it'll keep building up. That's called bioaccumulation, when it moves up the food chain. From there, we end up eating these larger organisms, and that's how microplastics get into our bodies. And from there, they can stay in our bodies for a very long time. They can, like a lot of you said, cause things like cancer, possibly dementia, which ideally we would avoid. We're going to do a bit of an activity now. So there's a link here. I'm going to put it in the chat as well. So what we're going to do is I'm going to put you in small groups of 5-ish. And you're going to go to this link and you're going to find your neighborhood where you live. You know, let me just send you this first so you can click around while I talk. There you go. So go to that link, find your neighborhood, and you'll see an option to delineate your watershed. What that will do is give you a red area of where your watershed is. So that's all the area that drains into the same river. You can see over here, I've done it for Manhattan, where I live. This right here is the Columbia office where this program is being run. All of this drains into the Hudson River. After that, you're going to trace the flow path. So what that does is connects your community and the river where you are to the ocean, because all the water on Earth is connected. You are going to be in small groups, so I want you to talk with each other, you know, what's different, what's the same. I've given you a few discussion questions over here just to get a conversation going. And I would recommend playing around with different views on the top right. It gives you a bunch of options just to, you know, see if you find anything interesting. Does that make sense to everyone? I don't see hands, so I'm going to take that as a yes. Let's give you 17 rooms. You'll have a while to work on this. I'll be moving around, so when I think conversations are kind of ending, I'll bring you all back. all of you still here? Can you you should have the option to join a breakout room. Hmm. If you put in the chat if you're trying to join a breakout room and it's not working, okay. I can see if I can do it from my end. That is so weird. If you guys want, you could just use this as your breakout room. You have a bit of a bigger group, but I think that should be okay. Just so at least you still get to do the activity. I'm gonna hop around. Hannah Radhika, you're in this room. If you can help them out. Hey, group one, how's it going?
What are we just finding our watersheds?
Find your watersheds and then think about what shape is it, how big is it, why might that be? And then think about, once you finish that, you can choose the option to trace the flow, which will point you from your river to the ocean. How long does it take? What communities are between you and the ocean? And then compare your answers and see if you find similarities.
Okay, cool.
Hi, group two, how's it going? Hi. You're all
Hi.
know what you're doing, it's working out.
Delineating our neighborhoods.
What was that?
Just exploring our neighborhoods in the software, in the MG Hydro.
Yeah. Compare answers, find trends and similarities. Good luck, have fun. Hi, group 3. How's it
Hi.
going?
It's going good.
You've noticed anything yet? How far are you guys?
So I placed the location in the polygon. I pressed the button, but I think it's still loading. But previously, when I did it, it's displayed like the rivers and how many there were, which were free, but it was in my location, so I'm redoing it.
All right.
I
If you
was
need,
able to trace paths that goes like from my neighborhood down to the ocean.
where do all of you live? Or like roughly?
I live in India.
All right.
I live in Southern California.
I live in Agadir, Morocco. I have a question.
Same here.
Yeah. What's up?
Can I share my screen to show you?
Go for it. Do you have the ability? You should.
I don't know how.
There's a share button in the bottom.
All right.
Sorry, while you're sharing screen, I'm gonna interject with a question for Crow because I had some questions come up in the other breakout room. So Crow, in the map, they're asking what is the kind of the difference between the dots? So there's like the blue dot and the pink dot.
Yeah.
If you share with me, I'll broadcast it to all the rooms.
All right. So one of the dots, I think it's the blue dot, is the location you picked, and then the pink dot is it's going to snap to the nearest river like data point they have. And if there should be a setting for how precise you make that. It takes a while if you put on the higher precision setting, but it's just like snapping to the nearest river point.
Okay, great.
Group 14 needs my help, so I'm going to let you all go.
I think maybe, yeah, if we can bring maybe some of them back too, because I think all of them might have similar questions. So if we can, yeah, that would be great.
I'm bouncing through them. Hey, group 14, how's it going?
Hi. We're not really sure what we're supposed to do. I tried doing it on my phone since my laptop is lagging. So
Exactly.
Were you able to open the website?
yes, I did delineate my neighborhood on my phone.
All right. Did it give you the red outline of your watershed?
Yes.
All right. What does it look like?
It's really an odd shape. It looks like a chicken. It's quite big since right now I'm not in my city, so I'm not familiar. I'm traveling, so I'm not familiar with this place. But yeah.
Is it between rivers? Are there bodies of water near you?
Yes, in fact, the city where I'm staying at is like a small island linked to a country, if you can understand. Like in all directions, there's seas and beaches, and yeah.
Yeah. Then I imagine your watershed looks really interesting.
Yeah, exactly.
Yeah. So I imagine it's fairly easy to trace your path to the ocean.
Yes.
What about the rest of you? Do you have anything interesting?
I had a hard time finding my community, but then I just found it.
All right. What does your watershed look like?
It's huge.
Yeah, some of them get really big. Are
It's
you
a
near
bit-
a coast?
Not really.
Yeah, I think if you get far from coast, then you're gonna get really big watersheds because all the land in the same area is going to drain into one river. And it's all going to take the same path to the ocean. I'm gonna bounce to another room, but good luck. Have fun.
Thank you.
Hi, group 9, how are we doing?
I'm good. I found my like neighborhood and I like traced the flow path and then delineated the watershed.
What does your flow path look like?
There's like kind of like a river. I think it's the Stony Brook River, so that leads out into the Atlantic Ocean.
Yeah, oh, then you're right by me.
Oh yeah, I live in New Jersey, like by
Yeah.
Princeton.
So yeah, we're close enough to the ocean that the flow path is pretty straightforward.
Yeah.
We have 25 seconds left, so I'm going to let you all go for the last 20 seconds.
Throw back to you for debrief.
Yeah, I'm gonna let everyone else trickle in, I think. Now the rooms are automatically closing.
Oh, great. Yeah, there's still people coming back, I see.
Yeah. All right, it looks like we have everyone because that number is no longer changing. So I'm going to share this again and open it up to you guys. Does anyone want to share anything interesting that they found? Hayne, if you can call names because I can't see everyone.
Sure, Shreyan, go ahead.
So everyone who was in like breakout room 13, most of our the rivers, they were upstream.
That's a commonality. Anyone else? I heard some interesting conversations. I know you have things to share.
Zarella, go ahead.
I found that like even though my like was it like the flow to the ocean was only like 500.
Go ahead, Zarella. Yeah.
Sorry. Even though it was only like 500 kilometers, it had a lot of connections with other water bodies. So even though it doesn't seem like my little area has a difference, it does.
That is a awesome point to make. Thank you.
Oh, sorry, is this working? I don't know because I'm on my phone. Is this all right?
Hi, is it Kahang? Okay, I'm gonna hand it over to Amukta. Go ahead.
I think like the others I mentioned before, my area also had a lot of streams, but it added up to a bigger water body. my area is also it depended because like some were landlocked and some weren't, and there's a big difference between being landlocked and not, because you have more access to water. Personally, I live in Houston, so we're having a hurricane right now, and because we're not landlocked, there's a really big difference in the weather and coastal regions as well.
Anvi, go ahead.
Yeah, I kind of had a similar thought. So where I'm based, which is like kind of near the coast, or like in the US, it's a state near the coast, like New Jersey. I noticed compared to like a lot of other states that are more landlocked or like inside the US, there's not as many watersheds, there are not as many like circulation of like the water. And I was a little confused on how the actual like chart worked. So would it be like, do we look at the red lines that are like closest to our location and then like delineate like its flow path? I just had a question on that too.
Yeah, so the watershed just notes everywhere that is going to be drained by the same river. So basically, if you're thinking in terms of water and plastic pollution, that's your community. You all have a shared impact. And then for the water flow, that's just going to trace whatever path that water takes to the ocean. So it goes through streams and rivers, and however long that takes to make it to a larger body of water.
Thank you.
I think we have time for one more, and then I'm gonna hand it over to our next speaker.
Maria Antonia, go ahead.
Thank you. I think in summary, studying watersheds show the plastic pollution can spread from different sources on land, impact nearby and faraway water ecosystems. Knowing watershed features help water effective plan to reduce plastic pollution, where it starts and as it moves through waterways.
Yeah, I heard a lot of you bring up great points. You have this link if you're ever curious about poking around in other communities or playing with the other tools that the site has. I would recommend it. It is quite fun. I'm going to hand it over to Lily now, who's going to be your next speaker.
Thank you so much, Crow. Is it okay for you to drive the slides?
Yeah, sure.
Okay, great. All right. Thank you again for having me. And it's so wonderful to see so many of you here. It's very inspiring, and really appreciate you being the bright lights of our future. We can go to the next slide. So my name is Lily Genovese. I am a marine scientist and outreach specialist for the Long Island Sound Steady Estuary Partnership, and I'm based in New York City. So I work for Cornell University and have an office at the New York City Department of Environmental Protection. So we could go to the next slide. I'm going to talk to you about Long Island Sound and our water effluent. Next slide, please. So I work for New York Sea Grant, same as Crow. We're on the same team together. We're going to talk about what is New York Sea Grant and the Long Island Sound study. What is the Long Island Sound? Why do we care? And then we're going to go into some of the water quality challenges of this estuary, as well as talking about our responsibilities in taking care of estuaries. Then we'll have a discussion. I have 3 questions here. Perhaps at the end of the presentation, we'll put those in the chat and we can all participate in a group discussion about some of these questions. So as I'm going through the presentation, these are things maybe you want to think about the wastewater in your area. I know we looked at, this map, this great activity that Crow had about mapping ourselves and figuring out, where our water goes. And then, really what our communities can do to improve the waterways, if there's any concerns, and what what you can do in your own individual areas. Next slide, please. So very quickly, New York Sea Grant is a college extension program. As I mentioned, I work for Cornell University. There are Sea Grant programs all throughout the United States, and we join in partnerships with organizations throughout our states, our partner states, and we do everything from funding to outreach to education. And this is one of our projects, actually, the Eco Ambassadors. Next slide, please. So what is an estuary? So I work for, the Long Island Sound Estuary Partnership. That's my main partner here in New York State. And an estuary is one of the most unique places in our planet. So many of you, I think even in my breakout room, we were having discussions about estuaries. These are some of the most productive ecosystems on the planet. They're places where the rivers meet the seas, and the Long Island Sound is an example of this estuary. It's one of the largest in the United States, and we're going to learn a few more details about it. So this mixing of fresh water and salt water, from the terrestrial ecosystems and then the oceans brings in a lot of nutrients, and it creates this super ecosystem for a lot of different animals to live in. We also call it nature's nursery because a lot of animals will come to reproduce in this sort of safe and nutrient-rich environment. Next slide, please. We already talked about what is a watershed. A watershed is that area of land where all of the water drains into a particular basin. And in my group, I got to share about how I live in a very unique watershed. It's actually the New York City's watershed. So where I live, there's a lot of protected land so that New York City can have this source of clean, unfiltered water. And we use about 1 billion gallons a day here in New York City. Next slide, please. So everything you do in the watershed ultimately impacts the water downstream from where you are. So this is the Long Island Sound watershed. As you can see, New York and the Long Island Sound is way down at the bottom of this map. But the watershed stretches all the way north to Canada. So any of those communities, any of those places in that green and pink and brown, that colored area on that map of the United States of the East Coast, that ultimately impacts this very important estuary. So there are many people that are having an impact on the estuary. And you guys each got to see in your own personal area, where your water goes. Maybe it goes to a particular stream or a wastewater treatment plant. And the final point is going to be somewhere in the ocean. So the ocean really starts where you are based. Next slide, please. Here's a closer zoom of the Long Island Sound. And just to orient folks, I'm located in the Western Basin. So if you look at the left side of this map, all the way to the left, you will see New York City. So New York City is made up of those 5 boroughs: Bronx, Queens, Staten Island, Manhattan, Brooklyn, and Queens and the Bronx directly border, and parts of Manhattan directly border the Long Island Sound in these Western Narrows. And just based on the map, you can see that the estuary has places that are very, very narrow. And so there's not a lot of movement of water in there. So it is a protected area. It's high in nutrients and there's a lot of wildlife here, but it's also challenge when it comes to management of our water quality. So next slide, please. The Long Island Sound is about 110 miles long and only 21 miles wide. So again, the Western Narrows on the very far left-hand side of the map, it's this tight area where there's, a lot of people living and huge populations, impacting the water directly from the coasts, but it doesn't have that impact of the effect of flushing. In addition to that, the Long Island Sound is also very shallow. So it's something else to consider in terms of the water quality. So it's only about 63 feet. And that has, in some places, that can mean a lot of different things in terms of where the sunlight is reaching in the estuary and the mixing of the water there and the temperatures as well. Some of you are talking about climate change. Climate change is a huge concern for this particular estuary. Next slide, please. More than 4 million people live in the coasts of the Long Island Sound, and in total, more than 23 million people are living within 50 miles. So you can imagine that this estuary is having, is impacted by many, many people. Next slide, please. These are just examples of some of the species that could be found in the Long Island Sound. I'm sorry if the slides aren't coming out properly. I think when they moved to Google, they got a little honked up. But we have everything from, these very unique diamondback terrapins to ospreys that come for the nesting grounds there, to things like oyster habitats and even oysters for consumption. So Long Island Sound is one of the producers of oyster aquaculture for the Northeast. So, even though, we have this huge population, this giant watershed with many people impacting the water, our water quality on our eastern portion of the sound is actually quite healthy and is healthy enough to be able to sustain this aquaculture industry. Next slide, please. So where we started, Long Island Sound hasn't always been, seen as this important and healthy wildlife sanctuary. In the past, there was a lot of issues with pollution and people really didn't have much hope for this estuary. However, in the last 10 years, the water quality has improved tremendously. And one of the most important changes that's supported this healthy growth of the estuary and changes in the estuary is the upgrades to our wastewater treatment system. So we're going to be talking a little bit about that. Next slide, please. So when the Long Island Sound Study formed in 1985, this was a bi-state partnership for New York and Connecticut. And the partnership of this estuary partnership, which is supported by the Environmental Protection Agency, or the EPA, it was really formed with this Clean Water Act. So there was policy that helped to influence, how people were taking care of the Long Island Sound. And that made a huge difference. When the Clean Water Act passed, that mandated that these waters be healthy enough for people to be able to go fishing and swimming in them. The communities really stepped up to do what they needed to do to ensure the health of the water quality. Next slide, please. So as I mentioned, wastewater treatment is, one of those actions that help to improve water quality. So previous to wastewater treatment facilities for New York City, raw sewage just went directly into the nearby harbors and bays and even the Long Island Sound estuary. And over time, with the Clean Water Act and people actually getting sick from some of the effluent that was just staying, in their communities, these changes were made, and now we have this process. The link on this slide here is actually a really cool story map, and I know you all are working on story maps. It's a story map of the DEP, the Department of Environmental Protection's wastewater treatment facility. So it takes you into the wastewater treatment facility, and you get to see the people that work there and the processes that take place once water from the 9 million people that live in New York City enters these wastewater treatment facilities. And there are actually 14 of them here in New York City. The largest one is the Newtown Creek Wastewater Treatment Plant. And if we go to the next slide, this is the curriculum that has the video for the wastewater treatment plant. Do you see the link for it there, Crow? Or maybe it's in the next one. Next slide. Yes. So here's where and what happens to sewage in New York City. And I hope you can share the video, Crow. So we'll take about 3 minutes to watch this really unique video of the wastewater treatment process. Do you see the link? It's right on the slide where it says, here's where New York City sewage really goes. No? Okay.
Can you guys not see it? Hang on, I can.
The video? No.
Yeah, okay, hang on, give me a sec.
The unique thing about Newtown Creek, it's this wastewater treatment plant that we'll see in the video is that it's the largest in New York City, and it's actually open to the public. So if you live in the New York City metropolitan area, you can actually visit the Newtown Creek Wastewater Treatment Center. You'd have to go through their website and request to join one of the tours that they give, and they have certain times of the year tours that you can participate in. You get to see the entire process, and many communities in this area and throughout the world will have tours of these facilities, so it's a very unique experience. Do you need any help with the link, Crow?
No, I have it. I was just waiting for you to
great.
finish talking.
Oh yeah, no, go ahead. Thank you. I can't hear the video, though.
All right. Let's troubleshoot again.
I encourage everyone, hopefully we'll share the story map. I encourage everyone to, take a peek at it.
Is the audio working now?
No audio.
No audio. Huh. That's weird, because this is how I did it last time and it worked.
Okay, you want to try again? Maybe it's me.
Is anyone else hearing audio?
Right now, no, but I think the video is stopped
It
right
is
now.
paused, yeah.
Oh, we don't hear it.
I think we do see the captions, though.
Sorry?
We see captions, but not the sound.
All right. If anyone else has a troubleshooting idea, because this is how it worked last time.
Maybe in a browser?
It is
in the browser, okay.
Maybe
Are
someone
the
else could try sharing the screen.
Yeah, Lily, if you want to try sharing the video, that might work.
Okay.
Water treatment plants. In total, we treat about 1.3 billion gallons per day. There are about 8.5 million people in New York City. All of their wastewater is treated at one of the 14 plants. Here at Newtown Creek, the service area is about 1.1 million people. This plant here at Newtown Creek, though, is the largest of the 14 plants. It treats, on average, about 225 million gallons a day. We receive sewage from parts of Brooklyn, a little bit of Queens, and actually almost the entire east side of Manhattan and lower Manhattan. We're right now at the lowest level of the facility, about 50 feet below street level, where the raw, untreated sewage enters the plant. We have the sewage pass through a series of metal bars that are spaced about 1 inch apart, and those bars remove anything that may get into the sewer system that could clog up pumps or other equipment. A lot of the material we do see are sanitary wipes, which, unlike toilet paper, really don't break down in the sewer system. So occasionally things wash up on the screens that shouldn't be in sewer systems. Fish, we get turtles, we get dollar bills from time to time. A few years ago, there was a firearm that came onto the screens. NYPD got involved with that. A lot of things that are in sewage can't be physically or mechanically removed. they have to be removed in other methods. So we remove that material here at what are called the aeration tanks. And in these tanks, we cultivate microorganisms that are naturally occurring, and they actually consume organic material that's in sewage, and that's part of what we call the biological treatment process here at the plant. We're now at a part of the process called the final settling tanks. Organic material that has now been consumed by microbes is heavy enough where it can settle to the bottom of these tanks and be physically removed for later processing. Obviously, treating sewage from 1 million people can be odorous, so we do a lot of odor control here at this plant. All of the tanks are essentially covered where there can be odors, and that odorous air that are trapped under the covers passes through activated charcoal, which removes a lot of the odor-causing materials. The organic material that we remove from the wastewater is called sewage sludge, and we now have a couple of processes for that material. One of them is called thickening. We're at the top of one of the 8 egg-shaped digesters here at the plant. We're about 140 feet in the air. It gives you a good view of the city. The purpose of digestion is fairly simple. We want to take the organic material that's in the sewage sludge, fats, proteins, carbohydrates, and break them down into more basic components like carbon dioxide, water vapor, and methane gas. And that's done here in these digesters. So as you see here, this is the last step in the process. We've added bleach to the wastewater, and it's leaving the plant at this point and going down to an outfall that releases the treated sewage into the East River. There are federal regulations that require all wastewater treatment plants in the country to remove at least 85% of the organic material that comes into a plant. This plant generally removes between 92 and 95% of the material, so we do better than federal standards.
So, oops. Sorry. So that was the wastewater treatment process, and can we go back to the slides, Crow? So what I was going to say is, you heard that, there's this process of skimming whatever's on top of the wastewater when the effluent initially comes in. A lot of microplastics and plastics are removed this way, but not all of them. As you've been learning, microplastics have different, and plastics have different, there are different types. So some of them float, some of them might attach to, other particles, and they might sink. So sometimes they get spread in this water column, just like Crow was mentioning. And so there are no regulations, mandating the removal specifically of microplastics. We have estimates of how much of it is removed through the effluent, but it's not one of the major contaminants that is being targeted through this process. So it's really important to think about, what we put down the drain, what we put down, our storm drains. A lot of New York City storm systems and other parts of the world, they're combined systems. So stormwater and sewage all get combined before they go to these wastewater treatment plants. And in cases where the wastewater treatment isn't happening because there's too much water coming in or there's too much effluent, that gets released in our city directly into the surrounding water bodies. So certainly something to think about for where we live. Next slide, please. We do have campaigns that encourage people to pick up litter in their local parks, on their streets, to reduce single-use plastic. And these are some of the examples of the projects and programs that we do and how to get involved. Next slide, please. And here's how to follow us on social media. And I invite you all to do that as well. So going back to our initial questions, maybe I can pop them here in the chat. We can maybe start to have a discussion about, what's happening to wastewater in your area and what are some of the concerns or things that your communities can do to help improve, the water in your surrounding communities, or in case anybody has any questions, I'll be happy to answer them. Thank you. We can probably stop the slides and we'll see if anybody has questions or comments and concerns. I see one question. What's the meaning of upstream and downstream? So upstream meaning where the water is coming from, and downstream is what we generally use to talk about where the water is going. So does anybody want to comment about what happens to wastewater in your area?
Bernice, go ahead.
Yeah, I'm not too familiar with my county actually, but I did a quick Google search and it says that I live in Southern California, so around LA, and it says that wastewater is piped into the LA River, Santa Monica Bay, and Los Angeles Harbor, and it exceeds the federal water quality standards to make sure that it's compatible with aquatic environments.
Yeah, Bernice, thank you. And I used to live in Southern California, and your water most likely goes to the Hyperion wastewater treatment facility, which is one of the best in the country. They actually go through a process that's further than New York City. So they do a primary treatment, a secondary treatment, and a tertiary treatment, which actually makes the water drinkable after treatment. So that's actually very unique for a major city. Thanks for sharing. I'm not sure who was next, but
Shivangi?
Yeah, ma'am.
Go ahead.
Ma'am, I'm from India, so over here, if we are not served by a public sewage system, the wastewater is processed through a septic tank and uh, uh, and for consumption and to reduce the solids. And the most clarified liquid goes to a drainage field for further microbial digestion and dispersion to plants, and evaporation happens to any as happens to any other water, including precipitation.
Great, thank you. Nihal?
I live in Singapore and we have around 4 waste management plants in Singapore. So it's all waste management plants are mandated to purify it so it's drinkable. And it's called New Water in Singapore since we don't have any of our own water resources. So we purify and filtrate the water that we already, the wastewater, and we are able to drink it as well. Thank you.
That's great. Amukta, go ahead.
Like in Southern California and Houston, we also have a primary, secondary, and tertiary filtration system, and it really kills out any like pathogens in the water that can be like disinfected easily. But my concerns with the wastewater in Houston is really because of the aging infrastructure, and then there's a lot of potential contamination from industrial sources and I guess big fossil plants here. So I think local communities can also improve their waterways by reducing pollution at source.
That's a great point. Thank you. Malak?
Well, actually, I live in Agadir, and here in my city, we do collect water. The wasted water we collected, and then it can be reused in irrigation, for example, industry. I mean, it's not wasted at all, but we can use it.
Maybe we have time for one more, and Lily, feel free to comment if there are any comments. Sarah, go ahead.
So I'm not very familiar with anything that happened, but my little brother that's right next to me has been there. He has visited with his class, and I would like to ask if he could talk about it, his experience and everything, if it's okay.
I think it's okay. Just briefly, yeah.
See. So hi everyone. My name is Ryan, and when I went there, I see there is a little bad smell, and the generator was working for 72 hours in the week.
Yeah, thank you. Yeah, I mean, something to consider is, as I mentioned, part of the plastic waste will get, removed from the effluent. So it's not directly going out into the water if we get to go through this wastewater treatment process in the first place. But whatever is skimmed on top, that's still going to go into landfill. And in case that we have heavy rain, not always is that water being filtered before it's released into, Long Island Sound, this really important estuary that is a nature's nursery and habitat for so many animals. So, it's important to think about, what we put in our water, and even in the street. There's a lot of things that we can think about, and maybe things that communities can work on to helping to improve the water quality. So thank you for all of your comments.
Thank you so much, Lily and Crow, today. I know there are a few more hands raised, but just because of time, I think we're going to have to end there today. But a little virtual and real round of applause for our speakers today. Lily and Crow, thank you so much, and for your partnership with us too, and sharing all your knowledge and experience with us as well. We'll see you back. So today, this week, we have 3 sessions because of scheduling that is happening with our New York team. So we're actually going to meet this week today, same time on Wednesday, and then same time on Friday as well. On Wednesday, our data team is back. Mariam is going to be presenting for us a little bit more on using your story maps, excuse me, and the GIS mapping along with and I know there are some questions related to that. So what we're going to do is, from our program team, we're going to be sending you an email by tomorrow. So please do check your inbox, going over some common questions that have come up regarding joining the Google Classroom. Some of you are still having issues about getting the ArcGIS license. So all of those things we're going to go over in the email. So please do take a look at the email. And then if you have any remaining questions, we'll get a chance to briefly go over it at the end of the day after all our speakers speak on Wednesday, as just some housekeeping. So please do join us back. Same link as today on Wednesday at 9 a.m. Eastern time. And have a great rest of the next 2 days. We'll see you back on Wednesday. Thanks, everyone.
Dan.
Bye.
Bye.
Bye, thank you.
Goodbye, get well soon.